Alright, in this video we are going to be talking about substitution reactions of alcohols. So first we're going to talk about SN1 reactions. So tertiary alcohols can undergo an SN1 reaction when it's treated with a hydrogen halide. So you can see in the overall reaction, you have a bromine here that is replacing that hydroxyl. So if we look at the mechanism here, if you remember, a hydroxyl is a really bad leaving group. So in order to make it a better leaving group, we have to protonate it first. So that is going to be step one. We have a proton transfer here. The oxygen is going to reach out and grab the hydrogen from the HBr, and then you're left with a positive charge on the oxygen. And then because it is tertiary, it is going to proceed in an SN1 fashion, and the leaving group is going to leave. And then you are left with a tertiary carbocation here. And then you have the bromide nucleophile, and that is going to attack the electrophile and replace the hydroxyl with the bromine. So we have several different SN2 reactions here, and they are all going to take place on primary and secondary alcohols. And we have several different reagents, so take a look at this list, but we are going to go through a few examples for each of these. The first ones we're going to talk about are primary alcohols treated with HBr and then HCl and zinc chloride. So first we have the primary alcohol treated with HBr. Hydroxyls are bad leaving groups, and so with this mechanism, even though it is SN2, that hydroxyl must still be protonated before the actual reaction can take place. So it's going to reach out, grab the hydrogen. That is going to leave a positive charge on this oxygen, and then the bromide is going to come and attack the electrophile, and that is going to kick out the leaving group, leaving you with a bromine instead of a hydroxyl group and water. So for HCl, we have zinc chloride, and zinc chloride is a Lewis acid, and it is going to act in the same way as if we were to protonate that oxygen. It's just a catalyst that makes the hydroxyl a better leaving group. So the first step is that this oxygen is going to reach out and grab that zinc chloride, adding it to itself. And so now we have an oxygen with a hydrogen and the zinc chloride and a positive charge. And that makes it a better leaving group. And so then the chloride is going to come attack the electrophile, kicking out the leaving group, and then you're just left with a chlorine on that carbon. So now we're going to talk about primary and secondary alcohols with TsCl chloride and pyrimidine and a nucleophile. So what TsCl chloride is it is used to convert a hydroxyl into a tosylate. And a tosylate is going to be a much better leaving group than a hydroxyl. So that's step one, turn the hydroxyl into a tosylate using TsCl chloride and pyrimidine is just a catalyst. And so also you need to pay attention to the stereochemistry here. So when we treat it with TsCl chloride and pyrimidine, we do not change the stereochem, we're left with OTS. And then that's a better leaving group. We can then use our nucleophile in a Br being the nucleophile, and that is going to come attack that electrophile, kicking out the tosylate. And notice that, like I said, we did not change stereochem when we treated it with TsCl chloride, but when we attacked it with that nucleophile, we flipped the stereochem for that. So that's definitely something that you need to pay attention to. Now we're going to talk about primary and secondary alcohols with SOCL2 and pyrimidine and then PBr3. So SOCL2 is going to be used to replace the hydroxyl with a chlorine. And again, the pyrimidine here is just going to act as a catalyst. And notice that this is going to invert the stereochem. So PBr3 is basically going to be the same idea. You're replacing the hydroxyl with a bromine, and that is going to invert the stereochem as well. So these are two reagents that you really need to know because you've never seen them before, and that's just something that you're going to have to memorize, and you need to know what they replace the hydroxyl with and that they both invert the stereochem. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.